Welcome to The Explainer. You ever feel like you're talking to a genius who has total amnesia? That's kind of the weird reality with AI today. But what if we could give it a perfect memory? Today, we're going to break down how we're teaching these incredibly smart tools to remember, well, everything. It's this weird paradox, right? One minute, you're working with an AI that feels like it can do anything. And the next, it has absolutely no idea what you were just talking about. It's more than just frustrating. It's a huge roadblock. So we're going to dig into exactly why this happens and explore the really cool solution that's giving AI, finally, a long-term memory.
All right, let's jump right into the heart of the problem, because this isn't just some minor quirk. It's probably the single biggest thing holding us back from creating the kind of truly helpful, long-term AI assistants that we've all been imagining.
Now here's the thing. This isn't a glitch, and it's not a bug. It's actually a fundamental limitation baked right into the design of these large language models. They're built to do these incredible things in a single instant, but they literally have no built-in way to remember the past. So what's the technical reason for this AI amnesia? Well, the answer is a single, really critical concept that works a lot like the memory in your computer. It's called the context window. The easiest way to get this is to think of the AI model itself as a super fast CPU. The context window, then, that's its RAM. It's the short-term, temporary workspace where it holds all the information it needs for whatever it's doing right now. But, and this is the key, it's a fixed and, honestly, a pretty small amount of space. Once that RAM is full, it is full. And here's where it gets crazy. Once your conversation gets a little too long, the earliest parts of it literally get pushed out of that RAM to make room for new stuff. And they're not just put aside, they are gone forever. This is exactly why an AI can't build a memory of your projects or your preferences from one day to the next. Its RAM gets completely wiped clean every single time. So how in the world do you get out of this context window trap? I mean, if the AI's internal memory, its RAM, is the bottleneck, the solution is actually brilliantly simple. You build it an external brain. You give it a massive hard drive. And the key to this whole external brain idea is a technique called retrieval augmented generation, or you'll hear it called RAG. This is the system that lets the AI CPU pull information from its new hard drive, something like a vector database, and then load it into its RAM, that context window, whenever it needs it. It's basically like giving the AI an open book test for every single thing you ask it. This shows you just how elegant the process is. First, you ask a question. The system then instantly searches its massive external hard drive for the most relevant files. Then, it pages that crucial information into the AI's RAM right next to your original question. And boom, now the CPU has all the context it needs to give a genuinely smart, informed answer. But just retrieving information is only half the battle. What if the data on that hard drive is conflicting, or it's old, or just plain wrong? This is where we take a huge leap forward, to an agent that doesn't just retrieve information, but actually reasons about what it should even bother loading into memory. And this slide just perfectly nails the difference between standard RAG and what's called Agentic RAG. We're going from a passive system that just fetches data to an active, intelligent operating system. An agentic system doesn't just grab the first thing it finds. It thinks critically about the information before it ever lets it get near the main processor's RAM. This is the absolute game changer. The agent becomes this powerful gatekeeper of knowledge. You can think of it like the memory management unit in a real computer's operating system. Before it passes any information to the main AI, it interrogates it. Is this relevant? Is it high quality? Do I have everything I need? It's like having a brilliant research assistant who double-checks every single source. So what does that actually look like? Well, for source validation, it can see that an official policy doc from 2025 is way more reliable than some old blog post from 2020, and it knows which one to load. For something complex, it can break the problem down into smaller steps, paging in only the exact context it needs into RAM for each tiny step, before putting the whole puzzle together. So what does this all mean for us? When you combine all this, the external hard drive, the smart agent acting like an operating system, you finally unlock the holy grail, the never-forgetting AI assistant. All of a sudden, a massive long-term request like this becomes totally possible. An agent with this kind of memory can manage this whole project for weeks, maybe even months. It keeps the big picture on its hard drive and only pages in the specific details, like budgets or flight options or feedback, when it's actively working on them. It's not trapped by its tiny short-term RAM anymore. And this is where things get really cool. This transforms the AI from just a tool you use into a proactive partner. It won't just wait for you to ask it something. It'll learn your goals and actively run processes in the background to help you get there. It can become this indispensable ally that helps you figure out and achieve ambitions you haven't even fully thought through yet. So here's the bottom line. By giving AI a perfect long-term memory, we're not just building a better chatbot. We are building the foundation for incredibly powerful systems that will work with us on our biggest, most ambitious goals. But as we build these perfect memories for them, it brings up a pretty profound question. What happens when our digital assistants know us better than we know ourselves?